Hey everyone, welcome to today's video. Imagine you have the most powerful Linux server in the world with the massive CPU, huge RAM, fast NVMe storage. But if you don't have that network cable plugged into that particular Linux server, then what useful thing that machine actually can do? It can run programs, it can write files, it can crunch numbers locally, but the moment you plug that network cable in, everything just changes. Now you can serve web traffic, you can talk to the databases, you can send API requests, you can stream logs, and it just becomes a node in a distributed system. In this video, I want to show you why Linux and networking are not just two separate topics, they are one topic, and modern infrastructure only makes sense when you understand both together. So without any further delay, let's jump into the topic. Let's think about a simple action which we do in a day-to-day basis by opening a website. So when you open a website from a user perspective, it feels very simple, but inside the system, something interesting is really happening. Your request doesn't stay inside one machine. Instead, it travels through multiple systems. What are the systems? First, your browser is where you actually look for the data or you try to access your application. From there, it moves to the DNS lookup stage where your data translates into an IP address. From there, it moves to the nearest edge server or to the CDN where your data will be moved to the nearest edge server. Finally, it will reach to the load balancer where it will be decided which backend server will be handling your request. From there, it will move to your application server where you run your code and you build the responses. Finally, it will reach to the databases to look for the particular data which you want to access or you want to get the information. So every step here is a network interaction between Linux machines, which means the real job of Linux is not just managing the processes, managing the memory. However, the real job of the Linux is moving the information between system reliably with the help of network. How exactly it happens in the depth of the system? Let's try to deep through. Inside the Linux kernel, there is a entire subsystem which is dedicated to networking. When a packet arrives at the machine, the journey actually begins. And it happens in a step-by-step manner. At the step one, the network interface card receives the raw packet from the wire. It can be from your fiber optic cable, or it can via your LAN, or it can via any other communication channel, physical communication channel, which can be present, which will be received at the stage one, which is nothing but your network interface card. Once it being done, then it will be moved to the step two, where your kernel driver will move it off the hardware into the networking stack. In this step, your hardware will be converting that communication to the network layer with the help of kernel driver. That is our step two. Once it is being done, in the step three, which is where our exactly network subsystem will be called, which is nothing but your IP processing. And in this stage, the packet will be confirming that this data has to come from this machine or not. So that is what the step three, which is nothing but your IP processing. Once it gets confirmed that this is the machine from where I have to receive the data, it will move to the step four, which is nothing but your TCP processing. Which stream does this belong to? Is anything missing or not? Is the communication or the packets are complete or not? It will be confirmed in this particular step, which is nothing but your TCP processing. At the stage 4, or the final stage of your network subsystem, your socket lookup happens, which means it will look for the process which is waiting for transmitting that data, or which process is waiting for this particular data. In this step, it will be confirmed. Once that process is confirmed, the process or the packet will finally reach your application, and this is from your data has to go to your requester, which is existing out of your Linux machine. So this is a step-by-step process which happens under the hood or under in your kernel. And the same things will happen in the reverse order when your server will be responding, or the data which will be transmitting from your application in the reverse order. How? Again, the kernel will be converting that data into packet, and that packet will travel across your switches, routers, networks until they reach another machine, the communication or these stages will be continuing. And this tiny mechanism is responsible for nearly all communication in modern infrastructure. There is no changes which has been done. You can, like, segregate into thinking it as a OSI layer or TCP IP layer, but this is just a tiny mechanism which happens under the hood, which will be same in all the modern infrastructure which we are using, whether it is a on-premise, whether it is a cloud system, or whether it is a serverless system, doesn't matter. This mechanism will be the same which will be happening under the hood. So what exactly the real system which is like happening over here? So let me give you a bigger frame here. For a longer period of time, we have been learning Linux as a standalone thing, like file systems, processes, users, file permissions, shell commands, shell scripts, etc., etc. That knowledge is valuable. I'm not denying to it. But in modern Linux, the Linux that running your cloud infrastructure, your Kubernetes clusters, your serverless architectures, that Linux is almost never running alone. Every Linux machine which you will be managing in your real engineering job is part of a cluster or a pipeline or a distributed systems. Most of the time we work on platforms which is not most of the time just a single machine. It can be cluster of machines, it can be cluster or a combination of multiple clusters, or in a distributed systems which our application might be running from. And the key point here is nothing but the combination of your knowledge of Linux as well as networking. So learning Linux without networking in a modern day is nothing but using a phone without a SIM card. You can have the device, you can play games, but it will not have a communication channel. So knowing both the things together and using it in your day-to-day job makes you not only a good engineer, but makes you a good production thinker or a good system thinker. So that is why combining both the knowledge in today's world is non-negotiable, and we should learn it parallelly. How we can learn both the things? What this mean practically, right? I define it as a mental model, which means you are learning Linux. Don't stop at the machine boundary. Learn how your machine is talking with other machines. Learn what are the sockets, how TCP is actually working. Learn how the DNS is doing under the hood. Learn how the load balancers are distributing the traffic. What are the different load balancer algorithms? How exactly your Kubernetes is managing networking, and how exactly it is working under the hood. Because those are not just advanced topics which you are trying to learn. They are actually the core topics. The sooner you connect all the dots, or you understand all the systems, how they are connecting with each other out and they are behaving in a production system, is very much required. And the faster you learn everything, it will be making sense much faster, because those are not just advanced topics which you want to learn or you want to apply later stage of your career, but they are the core topics. And the sooner you understand, the sooner you will realize how exactly the system is functioning and how exactly everything is just making sense in a production environment. So as a final note, I want to mention that Linux didn't become the backbone of the internet just because it is a great operating system. It became the backbone of the internet because it handles the networking better than any operating system available in today's world. And the kernel's networking stack are nothing but your socket APIs and the tools which we use in a day-to-day basis, like IP, SS, TCP dump, IP tables, NF tables, trace route. And these are not just the add-ons, and they are the central. And once you treat them as a central, your mental model of Linux just get a lot more useful. And in the next videos, we will go deeper into networking system, just not learning for interviews, but for understanding how exactly it works in a distributed system and how exactly it helps us to build the systems which holds the actual production. If it sounds something useful, then please stick around and don't forget to hit that like button and subscribe to our channel for more such videos in the future. It really helps a lot. And with that, we end today's video. And please let know your thoughts in the comment box, and we will be happy to answer and look into all your comments. And with that, we end today's video. Thanks for watching. See you next video.